We think about a timeline, and I want to take you through this quickly because I'll be using some of these terms. If you go back to the beginning, 4.567 billion years ago, when Earth first formed, and we come forward in time, 3 billion, 2 billion, 2,500, where some very interesting things happen to minerals, and going forward all the way to the modern time. All the things we think of when we talk about life forms really are in this last little bit here. And if you go to the paleobiology displays here, you'll see many of the classic specimens from Canada that have informed us and then told us how our planet has changed through time. But I'm going to be doing this from the point of view of minerals. Minerals are astonishingly beautiful. They're varied, and it turns out they have a history. Thousands of colorful minerals are found on Earth and nowhere else in the solar system. And why is that? Let's take that journey together. Why is Earth unique in its mineral diversity? Well, first, let's just talk about why minerals are so important, why we study them. First, they're critically important to all the raw materials that we use in industry and manufacturing, critical to agriculture and the formation of soils. Minerals have been drivers of scientific discovery. Many Nobel Prizes have been won for physics and chemistry studies of minerals. They also are key to understanding other planets and moons. When we go to Mars, when we go to other worlds, we need to know the mineralogy of those planets and moons because that tells us what's going on in the history. And of course, they're just astonishingly beautiful objects. So let's take a journey through time. The importance of mineralogy, when you think about the oldest thing that you can hold in your hand are certain very ancient rocks, meteorites. Some of them more than 4.5 billion years old. Nothing older that you can hold in your hand. They tell the stories of the origins, the evolution of planets and moons. And every single mineral specimen, when you go to the gorgeous displays here at this museum, every specimen has a history, it has a story, and it's information rich. It's a time capsule waiting to be opened. And so in 2008, as Kim mentioned, I introduced a field called mineral evolution. Seems like a strange concept. Do minerals really evolve? Well, the suites of minerals do. And what we look at in mineral evolution is the changing diversity and distribution of minerals as a consequence of new physical, chemical, and ultimately biological activities on our planet. Now, I'm going to use a term of art